Welcome, everyone. I'll give everyone a second to arrive in the room. Hello, hello. Nice to see you again. So welcome to presentation session B. My name is Megan. I'm your session chair today, and the general theme of our session now is community and engagement. For this session, we will have one full-length talk followed by 2 lightning talks. And as the session before, please pop any questions you have for our speakers into the live Q&A box, which you get to by clicking on the icon at the bottom of your screen. I don't want to take any time away from our presenters, so I'll go ahead and introduce our first speakers, Paula, Andrea, Martinez, and Sam Muirhead, presenting their talk, Translating Complex Topics, Software Containers. Welcome.
It's grayed out on that computer.
Hi everyone, is the sound all right?
I need to, the share screen is not, it's grayed out, I can't click it. Yes.
Okay, we'll do the introduction while we sort the slides. Okay, thanks everyone for being here today. We are going to present to you a video about software containers. My name is Paula Andrea Martinez. I am currently the software project coordinator at the Australian Data Commons, and before that I was the skills and outreach team for the development of this video. Sam Muirhead is the animator and he works for Camera Libre. Sam, you want to say a few words or you just...
Not right now, sorry, I just need to...
No, not yet. So the motivation to create an introductory video to explain software containers, we had our target audience to be non-technical people who are doing research. We thought we needed to fill a gap, the 101 video of the 001 of the 101 video. Most of the videos that we found currently available were very technical and use a lot of jargon words, and what we wanted to do is to bring examples from real life research focus projects so they will be more adaptable and understandable for the researchers.
No, I think I've got it. I think I've got it. Hang on.
I'll go to talk about the goals. We started with very clear goals. We wanted a short video and the target audience, again, researchers who needed to scale up.
So I should be sharing my screen, right?
Yes. Yep. Slide 5. Yeah. We wanted to motivate the wins of using software containers in research and include these 4 specific features: standardized, portable, reliable, and reproducible. We had a strong message of enabling reproducibility of results. Now, next, Sam is going to talk about the process.
Hang on, wait, I'm going to see. Yes, so the process. It was about 10 weeks of us working together on this project, so you can kind of see how the work was shared or how it evolved. There were a lot of different stages involved, and luckily Paula had already done a lot of work on clarifying the goals and the scope before I got involved. She'd worked with people within the organization on working out what needed to be said about software containers, who the target audience was, but we had quite a big unstructured document that we then had to kind of whittle down and turn into an animation script. And that involved quite a lot of whittling. We got it down to quite a short text, but the basic things that we needed were we needed our script to be nice and short. Basically, you don't have time with an animation compared to like a piece of text. You don't have time to kind of go back and reread to understand things. You have to get it the first time. And it also means that it costs a lot of, animation can cost a lot of time and effort to make. And so the longer the script is, the more work that there needs to be in post-production and in animation. So it needs to be short, needs to be clear and simple. And it also needs to make sense. So Paula had this idea of two colleagues in dialogue with one another, and it had to be casual and friendly. And so we had to make sure that the text also sounded like that, it sounded conversational. And the last thing is it has to kind of partner with the visuals as well. So the script doesn't need to say absolutely everything, because we actually have two mediums that we're using at the same time. We're using the text, and we've got the animations that are explaining things that are filling in more details. So the two can kind of work hand in hand. One of the things that we found when doing our early research into how something like software containers was explained already was that there were a lot of existing kind of icons that were just being thrown around, shipping containers, images of clouds and things like that. And that didn't really work so well, because you need to kind of keep in mind what all of those things mean, all of those disparate icons. We wanted kind of one unified visual language that we could use to explain this topic of software containers and explore all of the different benefits they have. And we soon realized that we were both using the same kind of drawing different shapes that didn't quite fit together, and drawing programs and little dependencies and so on. And so that was the basis of a kind of Tetris-based way of thinking about software containers, where you could have an app and its dependencies wrapped up in a nice tidy box. We basically didn't want to talk too much about the intricacies of dependencies. You can have to talk about a lot of kind of complicated jargon when you're describing what dependencies are and how they work and things like that. And so we basically tried to think a lot about how we would represent them visually, so we wouldn't have to talk about them too much in the video. This way we could kind of show that when an application can't access dependencies, or when dependencies aren't compatible, then that can cause problems for the application. And then it was easier to talk about software containers once we had that concept established. We were also able to use the examples of what kind of dependencies might be in a program, just to give people a little bit more of a something to grasp onto, rather than just talking in general conceptual terms all the time. So we could kind of show different programming languages and so on. And if you're familiar with them, then that's something that you can learn about. Yeah. Paula, do you want to talk about real life examples?
No, I wanted to talk about the real life examples that we use. We talk and discuss who can use this in terms of research projects, and we just selected a few. For example, image processing or brain image analysis, genome sequencing. Those are projects that can be improved their reproducibility and reliability of results by using containers. So we wanted to show them you can use this and it can help you. We go to the next one. We wanted to talk about portability of containers, giving also examples that you can build this in your laptop, but then it can be moved to a desktop computer, or if you needed more power, you can also move it to a high-performance computing or a bigger cluster. There is a thing that we wanted to explicitly not mention. So with multi-purpose and reusability in mind, we intentionally did not mention enabler technologies to exemplify just the concept of containers. And the idea is that this video can stay up to date even with new technologies emergence. The next slide is that we didn't want to leave, it's just a 3-minute video with credits, and we didn't want to leave with the message that now they need to go and reinvent the wheel. So we had 2 clear call to action messages. We actioned them to look for existing software containers on the web, and also search for the right support via their own institutions. And And all the information, it won't fit in the video, so we added into the description box. There's a lot of links that people can go for the next steps. Now let's watch the video.
Hey, I've been running my data analysis and I'm having some issues. My computer has just been updated and now the program isn't working.
Let's take a look. Your program relies upon your computer system and some supporting software to properly work. I guess if they've changed, things are likely to break. I've got an idea. I recently learned about something which could make your program more reliable and make your analysis easily reproducible too. Now I use it all the time and I think you can too.
What do you suggest?
Software containers.
What are software containers?
Containers are packaged software instructions. They include everything needed to run a program independently of the computer system. Depending on the program, that might include system settings, the programming language it's written in, or code for specific tasks like image processing or genome assembly. Software containers are named after shipping containers, as they have some similar features, particularly standardization and portability. Imagine you have a standard prepared software package that has everything you need to run your workflow, and that you can use in any computer.
So I could use my software container with any operating system, like Windows, Mac or Linux?
Yes, I use containers all the time because my containerized programs are easy to move from a laptop to a computer or a local or cloud server. If you need more power, you can even run your container on a supercomputer. Containers make programs portable.
Cool! I have a friend who wants to do a similar analysis to mine, but with datasets that span multiple years. Maybe she can use this container too?
Yep, no need to waste time reinventing solutions. For example, I have this program that generates plots from table data. Some of my collaborators had proprietary data that they couldn't share with me, but I could share the container with them to produce their own plots on their computers.
I like these containers already. What else are they useful for?
Normally, you might have one program that uses a particular version of some dependent software and another that needs a different version. But since a container brings everything it needs with it, it avoids conflicting dependencies. You can run multiple containerized programs and they stay completely separate. Containers also add security to your system. The computer where the container runs is protected, as the container can only modify things inside itself.
So containers allow me to reuse and to share my work across different systems. They improve the efficiency of my workflow, they make my analysis reproducible and therefore more valuable? I definitely need a container. How do I make one?
You could make your own container following public recipes, but first we can try to find a ready-to-use container with your software from the Research Computer Centre or in a global container repository.
That sounds like a great way to start.
Thank you, Lee. You can bring us back. Excellent. I hope you enjoyed the video. The link is also in our abstract. You have access to that. And what we wanted to finish with is this video was meant to be reusable. So we have a DOI. It's accessible by Zenodo with the description links that I mentioned before. It has a license of Creative Commons attribution, so you can use and share and adapt. Now Sam's going to talk a little bit about the source files.
Yeah, that's something that I didn't mention as I didn't introduce myself, is that what makes my work quite different from most animators is that I use free and open source software to make the animations and use open licenses and track everything and Git repositories and make that available as well, usually with some little helper scripts to make it easy for other people to adapt and kind of change or convert the animations for their own particular needs. And so this is something that Paula and I were working on through the process. I was working in the Git repository, and so that is then available if other people want to do translations. We've already got some interest from people wanting to do translations, or if they want to kind of update it or change it in the future, because normally animations and videos are quite hard to update and change, and so making it free and open source and available for other people update makes it possible for it to live on a little longer.
Thank you, and that's just right the time. If anyone has questions, we are happy to answer those.
Thanks, Paula, and thanks, Sam. That was so interesting. As containers become more popular and more in demand, it's really nice to see such an easy to understand explanation video. Gets me inspired. So as our presenters mentioned, we do have a few moments for questions. So if you have a question, please pop it into the live Q&A. I am going to see if there is any comments in the chat. Lots of people complimenting the video. So well done, guys. I do have a question, and I did ask this to Paula beforehand, but I was wondering if you had plans on making any other explanation videos, because it was just so lovely.
I think this is something that anyone else can take. Sam and I collaborated together with this. I fully recommend working with him. It was an amazing experience. I have moved to a new project, and for that one, we don't have any plans to make videos yet, but knowing how the process works, I'm really happy to talk to other people who want to do it. And I know Sam is also happy to talk about that.
I did have a question come in. What was the name of that open source animation program again?
So I'm using a program called Blender, which is traditionally used for 3D animation, but there's a part of Blender called Grease Pencil, which is for 2D animation, which combines a lot of the kind of traditional hand-drawn animation with all of the great stuff that modern 3D animation can offer. So.
And let's see, next question. Are you using any special way to store assets in the GitLab repository if they are big binary files?
They're usually not, the Blender files are big binary files, and I'm just chucking them in there, which is not the best way to do it. And but the assets are mostly SVG based, so all text based imagery. So that's easier.
Awesome. And just a comment from the crowd. Thanks for that. I can use the video to promote containers in my organization. So we've got some people very inspired to reuse.
Yes, definitely. That's what we want. We didn't brand it for any special organization apart from the one that paid for it. But that's the idea, that you can use it to advertise your own training, to advertise talking about it in discussions, or anything you want to do with your community. It's just the first part before you start talking in depth.
So cool. Thanks, guys. Thanks for creating that video, and thanks for sharing how you did it with us. Thanks, Paula and Sam. It's time to move on to our next speaker, Matt Plummer, who will be presenting a lightning talk titled Static Tactics, Using Static Website Workshops to Develop Capability and Collaboration. Welcome, Matt.
Kia ora tātou katoa. Can you hear me okay?
Yep, can hear you fine.
Perfect. Well, hello everyone. My name is Matt Plummer, and I'm a digital research consultant at Victoria University of Wellington. And I just want to give a quick run through today around a session not entirely dissimilar to the previous one, around how we can develop capability in fun and provide information in fun and interesting ways to help people gain new skills that can help their research career. And so one of the tactics I've arrived at to do this is to run workshops developing static websites, and the reason for this is that there is an immediate interest that a lot of researchers have in developing websites. They want their own website, but also there are a lot of collateral benefits. So these websites that I provide training in are free. They're static, so there's no database, which helps maintainability, and they're also Git-based, so there's an element of version control sort of built in by default, and an aspect of learning Git, which is kind of Trojan horsed into the process as well. The particular workshops I've been experimenting with are based on an open source Hugo theme called Academic, very widely used by researchers and academics. And there's an ecosystem that packages this up and makes it very quick and simple to deploy, packaged by Welcome and deployed by Netlify, and I'll give a very quick demonstration of that in a moment. It's based primarily in Markdown, so a nice, easy access markup language that people can get familiar with very quickly if they're not already. And the theme also supports a range of useful extensions for researchers such as math equations, code highlighting, and JavaScript diagrams, including many other things. It also, although you don't need to get under the hood at the first stage of my workshops, there is a way to further enhance sites with cascading style sheets, HTML, short codes, front matter, and configuration files. So all of these things are covered in different ways. And the results, here are a couple of sites, one I've developed and one developed by an attendee at a session I ran on this at RefBaz last year, to give you a sense of the kind of the look and feel of the finished products that are mobile responsive and, as I say, have a range of different configuration options. One of the things that I found useful to give attendees is a kind of a concept map overview of the ecosystem, because there are quite a few interrelated components, and it's quite ambitious to cover all these things. And what I've been running is 2 3-hour workshops, so a sort of a 2-part workshop. But you can see there that all of these things are gradually built upon, so it's not everything at once. You start with a deployed website and then go and edit a GitHub repository to see how that can propagate a change on the website, and then to using a text editor on a local machine and cloning a GitHub repository, and using either GitHub desktop or command line Git to build and develop the site. So why run these workshops? I mentioned it very briefly already, but intrinsic motivation. So it's fun. It's something that there's an immediate sort of payback, and it's something that seems useful. It's low risk and free to fail, so there's nothing hugely at stake if someone makes a mistake, and that's really important in learning. I think it's a really, really good way to teach version control, the benefits of it and the processes. People can see they've made a mistake and want to be able to reverse that, and also the sort of the language of committing and pushing and pulling, and the sort of the repetitive process of that. It encourages troubleshooting. So when people have a problem, we get into looking at deploy logs and looking around on the internet for help, and there's also help built into the workshops themselves. And one of the things that's really useful, I think, is that it does create a base level of skills for the people who engage with the workshops that can lead them on a journey which can be really helpful for rich collaboration and further capability development, and sort of further training such as carpentry. So I said previously immediacy, that it's pretty quick. So the first, a live site can be deployed and a first Git commit made within minutes of the workshop starting, and I've just done a sped up version. So this is where you go to a welcome you site, you click on the template, it whips up this, you connect to your GitHub account, it automatically creates a repository which you can name. You can then customize the name of the published website, and at this point you have a published website that's live, just a template. So then what I do is take them to their Git repository, go directly into GitHub and just edit one of the variables in their configuration file. And so you can see within a matter of minutes what's kind of happening and how it works, and also good practice such as adding a comment to your Git commit. And then when you refresh your page, you can see that change propagated. So immediately within seconds, people have got something that they can then sort of understand has an impact on how their work looks. We have a compute capability model, which is kind of a tiered structure model that we work to at our team. And this sort of workshop fits really well into those first 2 levels where you're starting to get familiar a bit with how your desktop works and how you can scale up and how you can leverage things like different web templating and also Git for version control, other things like that. So how have I done this? So I've based my workshops on a carpentry inspired model methodology with sticky notes for letting people know whether you're following informative feedback given on those sticky notes, a kind of a code along approach, good ratio of instructors and a helper if it is more than sort of say 10 people attending. And one of the great things I love about these workshops is it does accommodate different skill levels. So if you're right new, you can sort of just plod along and go at a quite slow pace. If you're experienced, you can race ahead and start adding and tweaking content to your website and actually getting a really rich concept, website developed. There's a modular scaffolded approach where we build on components and explain how they interrelate, and that develops over time. And those are the different kind of components that we work to. Future plans, I'm keen to formalize a lesson template and develop really good learning objectives that are kind of in my head at the moment but need to be extracted. To work with others to develop these kinds of workshops. There are already different iterations of them. And also to develop sessions which then follow along and help people build further capability with the different ecosystem that websites leverage, and also other things that sort of flow on from there. And that's my presentation.
Now we do have time for maybe a quick question before we go on to our next lightning talk. I'll wait a second to see if any come in. In the meantime, Matt, do you plan on running this workshop again soon?
Yes, so I ran the first one at ResBaz last year, an online ResBaz that was in November, and hoping to do something again at the end of November at this year's ResBaz.
That banner in your background, ResBaz coming up, woohoo. And maybe one more quick question from me, and while we wait for any others to roll in, do you have any tips for people that want to run a similar session? As you kind of said, it's a really fun way to learn version control, and version control is pretty tricky to learn. So I could see many people being interested in running similar kind of sessions.
Yeah, I think there's a community, I think, incubator software carpentry lesson on static websites, and there's also a programming history website, so you can look at that material. The reason I found that Welcome one that I've used as a template really useful is the documentation is pretty good, and you can get something live and up and running straight away if people have a GitHub account. So one of the things I didn't mention was that I asked people to say have a GitHub account and install a bit of the, have a text editor beforehand. And the feedback I also should mention has been really good.
Cool. Thanks for that, Matt. I will keep us moving along so we have time for our next presenter. Thanks again, Matt. So our last lightning talk for this session comes from Arindam Basu, and it's titled Communicating Epidemiological Insights Using Explorable Explanations. Welcome, Arindam.
Hi, can you hear me?
Yep.
Oh, great. The screen shows blank, so maybe I'll probably stop and restart sharing my screen. And this is going to be my talk. So I'll see if I can show you that. Not sure if you can see this, but let me see if I can bring up. Can you see my PowerPoint screen? Yeah, okay. So why don't I walk you through this a little bit. Well, just to start with, my name is Arindam Basu. I teach epidemiology at the School of Health Sciences, University of Canterbury. And the talk today is going to be focusing on how to epidemiological information and insights can be communicated. But as you will see as the talk will proceed, that it's not just about epidemiological information. Almost anything can be projected, and almost anything can be kind of communicated using a framework. But to focus on the epidemiologists, these are a couple of graphs on the recent global situation of COVID-19, and you will find them on. Okay, I'll see from the current slide if that can be done. Can you see that? Okay, fantastic. So this is what you get to see, is this that this is the World Health Organization's charts on COVID-19 at present. And you can see that they have created a couple of bar plots, which shows you the deaths and the confirmed cases. And that's one way of showing it up. Another way that has been quite traditional is this famous SNOWS map of cholera. You can see that there is a geographic information system. It's about 150 years old map. It still is taught quite widely across. And it's one of another way of communicating results from epidemiologists. A third way in which you can do that is you publish papers. So for example, Morbidity Mortality Weekly Report is a very popular form of presentations. It's usually done in the form of web page or PDF. And a fourth example is where you see that there is an interactive graphic presented by Our World in Data, again, in the context of COVID-19. It's very interactive. You can toggle on and off several components, and you can watch the graphs move. But all of these have got some limitations, because in each of these cases, new data continuously emerge, and as they do so, these graphs will need to be constantly updated. Therefore, it's quite wasteful if we were to redraw and remap everything over again. The third problem is this, that these are too author-centric. In other words, while epidemiological information needs to be communicated to the general members of the public, if the author controls all of it and the users cannot really make use of those information as they would like to create alternative scenarios, then the purpose of the communication may be lost. And it also talks about the issues of reproducibility of research and transparency. So in the past, some of these limitations were overcome by using dynamic documents. And I'm going to show you a couple of these. One is using SViv and RNW documents. So they would take LaTeX documents and they would really create reports. The second one is R Markdown and Knitr package. And a third one, Jupyter Notebooks. So take a look at this. This is a document where people could write LaTeX and they could write dynamic codes that would update itself as new data came in. And on the right-hand side, you see a PDF output. Another version is like R Markdown, where people can write Markdown documents. Again, you can update as new data come in, and you produce what is called an HTML document that people can read and constantly update. Jupyter Notebooks are very popular because these are the ones where you can simultaneously weave and tangle codes and texts, which also update themselves and get presented to the audience. And then there's a fourth class of materials, a fourth class of objects called dashboards. For example, Shiny, Dask, Power BI, Google Data Studio. And I'm going to show you a couple of them. This is a Shiny dashboard. But here what happens is this, that you do not convey any text information, but the user can manipulate the conditions of the graph and see for themselves what's happening. So we have got a mix of two worlds, right? Here is, for example, Google Data Studio, where you can manipulate charts and things like that. So dynamic documents are author-centric. And the reader and the user has got some active reading. But if you want to convey information on population health, epidemiological outbreaks and things like that, your user needs to both manipulate data and numbers. So just manipulating data as in dashboards is not good enough or insufficient, and reading them on static text for the last 200 years that we've been doing is fair, but it still is not very user-centric way of communicating information. So the question is, how might we extend these tools? Yes, and put a different paradigm. This is where explorable explanations come into the picture, where we do active reading and we tangle codes and woven words. So here is something where you could change the conditions of these numbers, and the document will dynamically and automatically change. You can try them on this website. And there is a tool, for example, Vigor Lite, that we use. So there is an implementation in a tool called CurveNote, where you can simultaneously put numbers that can change dynamically as well as you can put in figures, and the figures will dynamically change as you keep changing the context of the figures and create sliders. So to summarize, we see that there are ways in which we can now express epidemiological and complex information, which will let a user manipulate the conditions of the data, both in the text as well as in studying the graphics. So I'll stop there and take questions. Thank you.
We are running a little bit over time, so I will ask anyone in the crowd, if you have questions for Arindam, please go to the Meeting Hub and you can flick him a direct message there. Otherwise, we will see you at our next session, which begins at 2:00 p.m. That means we have about 55 minutes for lunch now. Thanks so much, Aaron. That was a really jam-packed lightning talk, and I'm sad we didn't quite have time for questions, but yeah, see you in the Meeting Hub and at our next session. Thanks, guys.
Thank you. Thanks.